Okay, welcome back. So we're going to do the next, I think we're going to do 5 more examples in your notes. So we are doing problem number 5 from your notes. And once again, I've already graphed it, but you are going to be responsible for graphing this on your own and knowing the shapes of these. So again, this is an easy problem. I'm going to show you how to find the intersections. We can, of course, look at this and see that it intersects at 1, 1. And here it intersects at -2, -2. But if I wanted to do that, if I didn't have the graph, I can set them equal to each other to find the points of intersection. So 2x squared is equal to x. I get x squared plus x minus 2 equals 0. That comes up a lot, it seems like. So this is x, x plus 2, x minus 1. Is that right? I'm going to go to positive 2 in the middle, positive 1 in the middle. And so we get x is equal to -2, x is equal to 1, which corresponds to what we got here. Okay, so once again, it's top minus bottom. So it's the top curve, 2 minus x squared, minus the bottom curve, x, and we integrate from -2 to 1. Now, I'm just setting these up because I'm really hoping that you can integrate from this point. Minus x squared over 2 plus 2x, and we're integrating that from -2 to 1. I can't use symmetry on this because these two areas are not the same, but you can do that on your own. Now, this is an interesting problem. Notice that the purple line is not always on top of the green line. So when I define this area, because this is the area I'm trying to find, the purple line is not always on top of the green line. And I can do this one of two ways. If I am determined to use x, one of the things that I can do is I can look and see, okay, up until this point, from this point to here, the purple line is always above the green line, okay? So that's one way that I could look at that. So I can make two integrations. I can integrate from 0 to 1, 2, and have the linear function, and I would have to do that in terms of y. So y would equal to x minus 1. So I could do this. This is the hard way. This is not the way we want to do it. And then we would subtract this one, but again, we'd have to do it in terms of x. So I have x minus 3, the negative of that, y is equal to the square root of the negative of that. Okay? Dx. But then I'd have to add the area from 2 to 3 of this function. So this is very messy and very ugly, and this is not the way that we want to do this. So this is not the way that we want to do this. The best way to do this, and especially since everything's in terms of y, is to do right minus left. And everything has to be in terms of y. So if I do that, the one that's to the right is this function, so I would do 3 minus y squared, the parabola's to the right, minus this function, y plus 1. And notice everything is in terms of y. Also, when we do this, this has to be y values. So my y value here is -2, and this y value is 1. So I would integrate from -2 to 1, and everything is in terms of y. Now, I'm basically just setting these up for you. I mean, we could do -2, 1, and have negative y squared minus y plus 2, and integrate that. Negative 1/3 y cubed minus y squared over 2 plus 2y, and evaluate that from -2 to 1. And I'm going to let you finish that, but I just want to get you in the habit of setting them up. Okay, that one took longer than I thought, so maybe we'll only do 2. Okay, this is an interesting one. Again, this may be something that you would have to do. Well, actually it says calculator active, but you could have to do this without a calculator. What I want you to notice is that the red curve is the cubic function, and of course the blue curve is the linear function. Notice there are times when the blue function is on top, and there are times when the red function is on top. So we have to break this up into 2 separate integrals. And I would have to integrate, I think, so I'm going to do it top minus bottom, and this point is 0, -1, and this, I'm sorry, yeah, that's 0, -1. This point is 1, 0, and this point is 2, 1. So my first curve would go from 0 to 1, and the blue function is on top, so it's x minus 1 minus the cube root of x minus 1, plus, I would integrate from 1 to 2. Now the red function is on top, so it will be the cubic root of x minus 1 minus x minus 1. Okay? So then you can integrate this. You'd have to do somewhat of a u substitution, but you can integrate this by hand. But I'm just going to let you find the answer using your calculator. All right, we have another one where we're going to have to break it up into 2 sections, because here we have to find this section where the red is on top. Again, this would definitely be a calculator active question, and you would just have to graph this on your calculator. Also on your calculator, you can also find your limits of integration. If you don't know how to do that on your calculator, please ask me on Monday, but you need to be able to find those limits on your calculator as well. So once again, we have 2 functions. We're going to break them up. This is -5. No, this is 0, -2. And well, that y value doesn't matter. This is 0, and this is 2. So my first one goes from -2 to 0, and the cubic function is on top. So it's 3x cubed minus x squared minus 10x minus -x squared plus 2x plus, and then we integrate from 0 to 2, and now the the quadratic function is on top, and we subtract that from the cubic function. And if I were you on this part, I would just use my calculator to integrate all of this. So you could just use your calculator. Another good thing here is to put this in y1 and this in y2. So you could also do, when you're on your calculator, which would be a less cumbersome, to do y1 minus y2 plus the integral from 0 to 2 of y2 minus y1. And if you put that in your calculator, you'll find that this becomes a little easier to integrate. Okay? All right, we have a couple more to do, so watch the next video.